Hello, and welcome back to lesson 4.2 from the exponential functions unit. If you remember my long rant at the, if you watched the previous video on lesson 4.1, you'll remember that I ranted at length about how we have to be familiar with all these different numbers that, correspond to the exponents. And it was rather short-sighted of me to give that lecture. Then, because as we see here, there's a nice table which basically gives you all the numbers that you have to remember anyway. So, no calculators, very important. And this is, again, to become more familiar with using these rules in a comfortable manner. And you might say, I'm at home right now. Nobody can catch me if I'm secretly using a calculator and cheating. I will say that using a calculator will actually slow you down. In this case, it is actually much quicker for you to learn these numbers and to learn these numbers and to be able to use them quickly in calculations will make your work a lot quicker and a lot easier than actually using a calculator. Important to keep that in mind. Just give me 1 second. Sorry about that. And again, hopefully we can fill in these numbers on our own. Here you can fill them in using a calculator. I'm actually not going to do that. I'm going to leave that up for you to do. Or if you go back to lesson 4.1 for my rant, I have basically haphazardly put these numbers on the top of the lesson. So view that. But obviously you can put these numbers in, and the idea is to be comfortable. You have to basically know these numbers almost instinctively, kind of like second nature kind of deal. This is the main thing we're going to talk about today, rational exponents. Now we're going to like a whole other kind of dimension. First, we had the case of negative exponents. So we'll refresh the distinction where the negative is in the base, like negative 10 squared, or something like negative half to the power of 2, or where the negative is part of the base, right? And this is just the negative. You just do negative 10 times negative 10, negative half times negative half, or if we make this a 3, the negative stays because it's an odd power, things like that. To contrast where the negative was actually in the exponent, where we have to flip the base, make this 1 over 10 squared, which is 1 over 100, very different, and something like, to the power of negative 3. Again, you flip the fraction, 2 to the power of positive 3, which becomes 8. So we'll see here very different calculations to do when you have a negative in the base versus a negative in the exponent. The same way, we're going to have to learn what to do when we have a fraction in the exponent. Up till now, we've only dealt with really like integer exponents, but now we're going to start talking about fractional exponents. And the good news is we've already seen these before. You know what this sign is. This is a square root sign. For example, square root of 64, you all know very well, is 8. What's technically invisible here is there's a 2 that's invisible. When I put the 2, means I'm doing the opposite of the square, taking the square root. In terms of exponents, what this looks like is actually 64 to the power of half. So this is actually 64 to the power of half is actually square root of 64. This root sign, or this root, this is called the root sign. And what that means is actually fractional exponent. So whatever number that is in here corresponds to the denominator of the exponent. For example, cube root of 64. And this is how I write the cube root. I just draw the root sign and I put a 3 there to indicate that I'm taking the cube root. And this is equal to 4. Or 64 to the 1/3 equals 4. Right? 64 to the 6th root. Again, root sign with a 6. This is actually 64 to the power of 1 over 6, which is actually equal to 2. So hopefully we'll see how we're doing this. The root sign really corresponds to a fractional exponent, or the denominator, if you will, of the fraction. So again, square root of 81 is 81 to the power of half. which is 9, right? So now we're getting smaller. Instead of 9 squared, we're doing 81 to the power of half. So hopefully so as an example, I'll do the 3. So this is 9, 27, 81. So 9 to the power of half is 3, because that's the opposite of squared. 27 to the power of 1/3. The cube root of 27 is 3, the opposite of cubed. 81 to the 1/4. It's the 4th root, opposite of to the power of 4. That's also 3. So hopefully we're seeing the usefulness of this table, and we can appreciate why it's useful to learn that table. So cube root of 8 is 8 to the power of 1/3, which is in fact 2. So again, it's important to be familiar with like the table here that we have not completed, but well, you have completed, and use that. So basically, there's another way of thinking about this is like 8 to the power of 1/3 or 243 to the power of 1/5 is like what to the power of 5 will give me 243. That's 3, right? So 243 to the power of 1/5 is 5. And however you're going to use this thinking, it's important to kind of know the tables and how to use them, etc., etc. So I don't know if there's any other way I can. You just have to know these things. If you put this in a calculator like 243 and you put the exponent and you put 1 to the 1/5, you will technically get the same answer. But again, no, you should be doing this without a calculator. Notice here that because essentially what I'm doing here is x to the power of m over n, I will point out that here you can take the nth root of x to the power of m. So you can do x to the power of m first and then take the nth root of that. Or you can take the nth root of x first and then do that to the power of m. It doesn't matter which order you do it. You can do, so for example, if I had 8 to the power of 2/3, I can do the 8 squared first and then take that to the power of 1/3. So 8 squared is 64 to the power of 1/3, which is equal to 4. Or I can also do 8 to the power of 1/3 first and then take the square of that, which is 8 to the power of 1/3 is 2. 2 squared is 4. So you see we got the same answer. And the idea is essentially you're splitting this fraction into 2 parts. You're splitting it in the numerator and the denominator. The denominator is considered the root. So you're doing like, cube root of 64 here essentially is what you're doing. And yeah, sorry. Sorry, I just got confused there for a second. Getting back to this. So again, 64 to the power of half. You can, again, as long as you know that what you're doing here is the square root of 64, you're fine. It gives you 8. 49 to the negative half. Very careful here. So first, we have to deal with this negative that's in the exponent. That's problematic. So here, 49 is the numerator. I'm going to move that to the denominator and then throw on this half. So here, again, very important, the half being a root sign, not anything to do with flipping the base or anything. And essentially what you're doing is square root of 49. As long as you know that that's what you're doing, that's fine. You get 1/7. There's negatives all over the place, but that's fine because we're going to leave this negative 100 as right there. That's part of the base. I'm not too worried about that. So let's take a look here. This is weird. Is this just me? This is weird. I'll have to take a look at the answer key. But what I think this is actually, like the negative stays as part of the 100. So negative 100 to the power of negative half. So I have to leave the negative as part of this negative as part of the 100. That's part of the base. This negative is what I'm going to deal with first. So this 100 is in the numerator. I'm going to move that to the denominator and put the 1 there. And whoops, this is to the power of half, 100 to the power of half. And again, what I'm doing there is really taking square root of negative 100, which is not possible. So I don't know. Pretty sure that's right, even though this is like no real solutions, but that's interesting. Whatever. Moving on, 8 to the power, negative 8 to the power of 1 over 3. Again, essentially what you need to be understanding here is you're doing the cube root of negative 8. And it's not like the square, so we know that square roots of negative numbers don't exist because there's nothing. Essentially what I'm asking myself is what number squared is going to give me negative 100, and it's impossible. There's no number squared that's going to give me negative 100, I mean, no real number. So that's why this answer is impossible. It does not exist. But actually the cube root of negative numbers do exist because of the fact that if I take negative 2 times negative 2 times negative 2, I get negative 8. So cube root of negative 8 is in fact negative 2. So be careful there. Very, very tricky stuff. So again, very similar vibes to this question. Negative 125 here appears to be my base. Although I can actually can I just ignore that? Is that 100 in a bracket? Yeah, the 100 was in a bracket here. The negative was in the bracket. This negative is not in the bracket, so I'm just going to do this first, and leave the negative outside. So 125, first I have the negative in the exponent, so I'm going to move this 125 to the denominator, make this a positive exponent. 125 to the 1/3 is the cube root of 125, which is in fact 5. So this is negative 1 over 5. And that's my answer. Moving on. Let's write in radical form. Okay, this is very, very easy. Cube root of 64. This is the other form of this question. It's the root form. And if you wanted to evaluate this is 4, but I don't think the question asks for that. And this is actually the example that we talked about before. You can write this as cube root of 8 squared, which would work because you're doing cube root of 64, which is 4. Or you could actually write this as cube root of 8, the whole squared, which is actually cube root of 8 is 2 squared, which is also 4. So you get the same answer here. And whichever way you want to write it, that's really fine. In some cases, it might be useful to do one way versus the other, and you kind of have to work with that as you come along. I don't think it really matters here. I mean, kind of. Okay, so remember that assuming you're being truthful to ourselves and we're not using a calculator, the easiest thing would be to take the square root of 25 first and then cube that value. Because if you take the 25 cubed, I don't even know what 25 cubed is. I think it's 150625, and then you could take the square root of that. You would get the same answer, but this is just square root of 25 is 5 cubed, which is 125. And I find this to be more easier to do if you make the number smaller. And you make the number smaller by doing the root first, or the denominator first. Again, this is 25 to the power of half that I'm doing first, and then raised to the power of 3, right? So I'm kind of splitting this 3 over 2 into half times 3 and redoing the power of a power law, or going backwards there. So I'm doing this first, which is 5 to the power of 3. Same case over here. First I do, this is again one of those weird ones. What? Oh, no, never mind. The negative, again, be very careful as to where the negative is, whether it's inside the bracket or outside the bracket. Here the negative is outside the bracket, so I'm just going to leave it outside and just do this as my simplification. Again, first I'm going to take to the 6th root, and then I'm going to do that to the power of 5, because I don't really want to be doing 64 to the power of 5 without a calculator. 6th root of 64 is 2 to the power of 5, which is negative 32 is my answer. So hopefully we're seeing how we're doing these questions. we're going to write this as 3 over 2 so as to be clear. And again, here's one of those weird cases where I'm apparently taking the square root of a negative number. So let me explain what I did there. So here, again, square root of this was like negative 9. I'm actually going to take the cube first and then take the square root of that. So negative 9 cubed is negative 243 square root, which is negative square root of negative 243, which actually does not exist. So I don't know what's up with that. That's weird. There's no real solutions for this question. 81 to the power of negative 0.75. Okay, we have to be very comfortable converting decimals to fractions. Hopefully we're okay with that. Negative 0.75 is 3/4. So here we have, again, first I'm going to do the power. Okay, first I'm going to get rid of the negative, make this 1 over 81 to the power of 3 over 4. That's what I'm going to do first. And then I'm going to actually take the 4th root of 81, because I know that's 3, and that gives me a nice small number here to take the cube of, which is 1 over 27. Again, you could have probably done 81 cubed first and then taken the 4th root of that, but without a calculator, that's almost impossible talk in your head. So again, here the idea is this is 64. First I'm going to take the cube root because I can do that. I know that's 4. Squared is 16. Another one of these weird ones. Okay, negative 243. I know 0.6 is negative 3 over 5. How do I know that? I know 0.6 is 6 over 10, and then I'm just simplifying that to lowest terms, 3 over 5. So first, again, this negative is just going to stay outside until the end because it's outside the exponent. This negative is going to stay with me, stay with the base, this negative. This negative I'm going to get rid of by moving 243 to the denominator. So here I will have negative of 5th root of negative 243, the whole cubed. So this is equal to the negative 5th root of negative 243 actually exists because it's an odd root, which makes my answer negative. So negative 3 cubed is negative 27. So negative 1 over negative 27 is positive 1 over 27. And hopefully we get that. That's the answer we're getting. Oh, there's a worksheet for you to do somewhere. You will hopefully find this worksheet 4.2 and do the homework. Again, if there should be a worksheet 4.2. I'm too lazy to go to the hub and find it, but hopefully it's there. If not, of course, you have 229. Oh, questions 1 and 2. Write in radical form, evaluate without using a calculator. Nothing is too complicated here that I can see. Write in exponent form and then evaluate. Again, nothing too complicated here that I can see. Really, the only... Again, things like this, you can write in exponent form 27 to the power of 2 over 3, right? That's converting it into exponent form. This is 5 1/12 to the power of 1 over 9. Again, the root means it's the denominator of the exponent. Negative 27 to the power of 1 over 3. And when it asks to evaluate without using a calculator, here you would do the cube root of 27 first, which is 3, and then take the square of that, which is 9. Doing 27 squared is possible, I suppose. It's not too much work. It's 729. And you know 9 cubed is 729, so it's not that big a deal, but it's easier to do it this way. Likewise, this is negative 6 to the power of 5. Okay, let's take a look at E and F just quickly. Again, the fifth root applies to both 32 and the 243. So 2 to the power of 5, negative 2 to the power of 5 is negative 32. 3 to the power of 5 is 243. This is my answer. This is probably the most confusing looking one, but realistically, let's take a look at this. I have a fraction to the power of negative 1. I'm just going to make that a positive 1 to avoid any troubles. And then this is 81 to the power of 1 over 4 divided by 16 to the power of 1 over 4, which is in fact 3 over 2. And that's my answer. So again, just fairly straightforward stuff, I'd say. Nothing too confusing. So of course, in the next lesson, we are going to talk about radical exponents 2, which is kind of a little bit more complicated because we'll see here we have to simplify stuff. So there's going to be some, using adding fractions, subtracting fractions in the exponent part of our question. So slightly more trickier, but nothing we can't handle, I'm sure. There's going to be a lot of homework. So this was a short video, but the next video is going to be, I'd say, pretty long because I'm going to be going over some of these, a lot of these questions. So I will talk to you soon. Peace out.